Welcome again. We are going to continue with the 19th chapter, Thermodynamics, and today we'll be studying the first law of thermodynamics and its application to the various thermodynamic processes. The first law of thermodynamics is simply the law of conservation of energy applied to any system in which energy transformation from or to the surrounding is taken into consideration. According to the first law of thermodynamics, if some heat is applied to the system which is capable of doing work, then the quantity of heat absorbed by the system is equal to the sum of increase in the internal energy and the external work done by the system on the surroundings. So if delta Q is the heat supplied to the system by the surroundings, delta W is the work done on the surroundings, and delta U is the change in the internal energy, then according to the first law, delta Q is equal to delta U plus delta W. In the previous video, we had studied that the work done in a thermodynamic process is P into delta V. So substituting that, we get delta Q is equal to delta U plus P delta V. Let us apply the first law of thermodynamics to the various thermodynamic processes. A thermodynamic process is said to occur if the thermodynamic variables of a system undergo a change with time. So the first process that we'll consider is a cyclic process. Now, in a cyclic process, the system returns to its initial state after undergoing a series of change. As internal energy is a state function, so delta U is 0 for a cyclic process, and therefore from the first law of thermodynamics we get delta Q is equal to delta W. Hence, in a cyclic process, the total heat absorbed by a system is equal to the work done by the system. In an isolated system, there is no exchange of heat and no work is done by the system or on the system. Therefore, Q and W are equal to 0. Thus, there is no change in the internal energy. Delta U is equal to 0. Isobaric process. Now, isobaric process is a process that takes place at a constant pressure. So if the pressure remains constant and the volume changes, the work done is equal to P delta V, and therefore the first law of thermodynamics remains same, that is, the heat energy supplied is partly used in increasing the internal energy and partly to do work. Isochoric process. An isochoric process is one in which the volume of the system remains unchanged, that is, delta V is 0. So when delta V is 0, the work done will be 0, and therefore by the first law of thermodynamics, delta Q will be equal to delta U. That is, the heat energy supplied will be used up in increasing the internal energy of the system. Isothermal process. An isothermal process is one in which there is no change in the temperature. So the internal energy of the gas, as we know, depends only on the temperature. Therefore, in an isothermal process, delta U is 0. Applying it to the first law of thermodynamics, we get delta Q is equal to P delta V. So, when the gas expands isothermally, P delta V is positive, the work done will be positive, and when it is compressed, the work done will be negative, or the heat energy will also be negative. In an isothermal expansion or compression, the internal energy of the system remains unchanged. An adiabatic process is one in which the pressure, volume, and temperature of the system change, but there is no exchange of heat between the systems and the surroundings. So if we consider a gas enclosed in a cylinder having perfectly insulated walls, then the gas is allowed to expand quickly. Then in this process, the work done by the gas during its expansion and its internal energy decreases. As the heat cannot enter the system from the surroundings, so the temperature falls. The essential condition of the adiabatic process to take place is that the compression and expansion should be sudden. Now, as there is no exchange of heat energy, delta Q is 0. So applying the first law of thermodynamics to the adiabatic process, we get delta U is equal to minus delta W. So we get the change in internal energy is equal to the magnitude of the work done by the system. If you see the table here, it tells about the various features of the processes and their relation as per the first law of thermodynamics.